Today we shall explore the importance of the induction coil and the capacitor and their characteristic behavior in AC circuits. I have drawn three circuits. This AC circuit containing resistor, the AC circuit containing induction coil, and the AC circuit containing capacitor. I have already explained in the previous class the complete details about the AC voltage applied to resistor. When AC is applied to resistor, the power is dissipated in the form of heat energy. Electric energy is dissipated in the form of heat energy, go as a waste by this resistor. It opposes the flow of current in that way. Resistance to the current opposes the flow of current in the circuit. Because of AC in the circuit, both voltage and current are variable in both magnitude and direction. The variation is similar to sinusoidal wave. This is sinusoidal wave, one wave, and it has two sinusoidal waves. One, the blue line for the voltage and the reddish line for the current. Both of them are variable in magnitude and direction. That is a variation of voltage, increase, decrease, and other direction, increase and decrease. This upper curve is the voltage in one direction, this voltage in other direction. Here also the current in one direction, current in the other direction. Variation of current, that is sinusoidal wave. Both are similar sinusoidal waves. Both of them are in the same phase. There is no difference in phase between them. The peak values are coincided, zero values are coincided. And the equation for the voltage, equation for the current in the circuit, these equations, we call them. Look at that. These two are the graphical representation of voltage, mathematical representation. The graphical representation of current and mathematical representation of current. Look at the difference. Difference in phase, there is no difference in phase. Sin omega t, sin omega t. Same phase. Current and voltage are in the same phase. That is the graph at this point. Let us see what difference you are finding in this circuit and in this circuit. In these two circuits, we find the phase difference between the current and the voltage. We see in the form of sinusoidal wave. To understand the difference, let us go for a mathematical solution to this problem. Mathematical solution to this concept. And the graphical representation of the resultant. We see what is the mathematical approach for this solution. mathematical approach for this solution. And finally, what the result we get, mathematical equation is written, then graphical representation. Then we understand the phase difference. Let us go for mathematical approach. This is a closed circuit. Kirchhoff's loop rule is applicable. Sigma of epsilon equals 0. This stands for EMF. Sum of the EMF is the circuits where there is no resistor. Where there is a voltage, there is a voltage. Here applied voltage, it is generated, it is induced voltage. It is in opposite direction, it is supplied. Therefore, it is sum of the voltages V plus V. This V is minus E. Voltage in this is minus V. Why minus V? It is induced voltage, but in the opposite direction. Induction coil. Recall the expression for minus V, that is from the previous class. Minus L into di by dt. Minus L into di dt, that is inductance, coefficient of self-inductance and rate of change of current. This is for this one, minus of this. And rewrite this equation. This is one rearrangement and further rearrangement and further rearrangement. Gi cross multiplying this, you finally get this equation. Equation of di. Let us solve for I from this equation. What equation you get? So di equals this one, V into d theta by L, dt by L. So what is V in this circuit? It is AC voltage. V is AC voltage. That is V equals Vm into sin omega t. Voltage in this circuit, that is AC source, is Vm into sin of omega t. You know omega is the angular frequency in the time. Substitute this into the equation. That is V. So this is V into, write the same, dt by L. And solve for I. Rewrite this equation. That is, these two are constants. These two are constants. Let us integrate to get the value of I. Integration of left hand side, integration of the right hand side. Integration of the variable, integration of the value, these two are constants. The integration of sin omega t with respect to t, that is sin theta with respect to theta, like this. It is minus cos of omega t. It is omega t, again differentiation of this, that is in the denominator. Differentiation of omega t with respect to t is omega, denominator. So this is integral function of this. Plus C, the constant of integration. Constant of integration. So I is equal to this one, minus cos omega t. Here the constant of integration is 0, since I is an oscillatory function. I is an oscillatory function. What is the meaning of oscillatory function? A repetitive cycle. I is a repetitive cycle, sinusoidal cycle. That is a sinusoidal cycle. The same thing is repeated all over. It is called as oscillatory function. That is pattern. the same pattern occurs over and over again in the same order over a period of time. That is a repetitive cycle. For that kind of function, the integration constant will be 0. That is why c equals 0. Then finally I is equal to this rearrangement. And write cos in terms of sine, because all are in sine waves. Recall the identity, trigonometric identity. Minus cos theta equals sine of theta minus pi by 2. So you can write as minus of cos as sine of omega t minus pi by t. I equals, now this is a constant, that is Vm divided by omega L as Im. I is equal to Im into sine omega t minus pi by 2. This Vm by omega L equals Im. Later explain this equation, what is omega L and this. I equals Im into sine omega t minus pi by 2. Now you have taken this equation, and when you solve for I in this circuit, we get this I. Look at the difference. If the AC circuit contains resistor, we have V and I are same, sine omega t, sine omega t. But here, when you take this is a AC circle containing inductor, we have this concept. Look at this. V is equal to Vm sine omega t, that is the voltage. But the current equation is, that is sinusoidal equation is Im sine omega t minus pi by 2. Both are sinusoidal equation. Look the difference. This is theta is omega t minus pi by 2. What difference you are finding? That is minus pi by 2. That is the phase angle difference. They are differ by pi by 2. The phase is differ. Here the phase is same. How does you write this? It is current minus pi by 2. It lags the voltage. Current lags behind the voltage. Voltage, then current. Here voltage curve, then the current here. Delayed. Current sinusoidal wave is delayed, voltage progressing as it is. So it is delayed by the phase of pi by 2. I lags behind the applied voltage by pi by 2. This is what we get. Mathematical approach, finally solution, and the graphical representation. Look at the difference. They are not in phase. The phase difference between the two waves, the voltage wave and the current wave, by difference of pi by 2. I lags V by pi by 2 minus pi by 2. Let us apply the same kind of mathematical approach to this capacitor, AC circuit containing capacitor. Recall the definition of capacitance. C is equal to Q by V. The charges accumulated on the plates, plus minus, that is divided by voltage applied between these two. And rearrangement, that is rewrite the equation as V is equal to Q by C. Now this equation is similar to Kirchhoff's loop rule. That is a closed loop. What is V stands for? Sinusoidal, that is voltage applied, the voltage of the source. What is Q by C? The voltage generated across the capacitor. The voltage generated across the capacitor Q by C due to this voltage. Here voltage applied, voltage is generated. It is thus generated, it is in the opposite direction. Therefore, this minus this equals 0 or V is equal to Q by C, similar to this equation. Voltage induced, voltage generated. Voltage induced by the rate of change of current. Here voltage generated across the capacitor by the application of this voltage. Now we have to solve for I. How do you solve for I? The equation for the current in a circuit, any equation, that is any circuit, dq by dt, rate of change of flow of current with time. It is I current. Substitute for Q from these equations. We can write this equation as this equation, V into C, and V as, the V is, what is that? AC voltage. Write the equation for AC voltage. Vm into sine omega t, C as it is. Q is equal to this into this. Substitute for Q into this equation, we get this equation. This is a differential equation. I is equal to d by dt of this. d by dt of this. To get I, you have to differentiate this equation with respect to t. Differentiation of this equation. Here these two are constants. These two are becomes constant. Constant into differentiation of sine omega t. It is cos omega. Differentiation of sine is cos. Theta is omega t. This omega t into differentiation of omega t with respect to t. That is omega into this. We get this. So the differentiation of this is cos omega t into omega. And together I am writing this Vm omega c sine of omega t plus pi by 2. Write cos in terms of sine. Here plus cos theta is equal to sine of theta plus pi by 2 using trigonometric identity. So it becomes sine of omega t plus pi by 2. So these are constants Vm. So these constants are known as Im. All this is equal to Im. The final equation is I is equal to Im into sine of omega t plus pi by 2. Sine of omega t plus pi by 2. Final equation is this, where here Vm omega c, that is what is that? This is Im. Omega say Vm into omega c, this whole thing is Vm. So Im, sorry. I is equal to Im into omega. Where you can write, let us explain this. What is this? Im is equal to this. Look at that final equation after solving for I. When you apply for this voltage, when you apply this sinusoidal wave, we get this current sinusoidal wave. What is the difference here? Pi by 2, it is plus pi by 2. Plus pi by 2, current means plus. So phase difference, here current leads the voltage. Current leads the voltage, sine omega t. pi by 2. Leads means plus, leads the voltage. So by pi by 2, how to represent in graphical form? This is a representation. This is different from this. This is a voltage. This is a current. Here pi by 2 difference here. Current is leading. Voltage is delaying. Here this current, then voltage. Here peak. Commencing from here, first here, then this, like this. Voltage lags behind the current, either way, by pi by 2, or current leads the voltage. Voltage lags the current, either way you can say, by a phase difference of pi by 2. Look at the difference. These sinusoidal waves we get from this circuit. Voltage is lagging behind. Here current is lagging behind. Delay in this sinusoidal, one is delay, other is fast. That is leads. What is the reason? The reason for this here, why the current is delayed? Because of this induction coil. You know that induction coil works by variation of current. So voltage is applied, it also offers voltage, but variation of current. So induced EMF in the induction, it is due to variation of current. Current is varying like this, increase and decrease in one direction. Immediately after, polarity changes. Current flow in the other direction. This is for the current flow in one direction. This is for the current flow in the other direction, one cycle. The same cycle is repeated. So what happens in the induction coil? Your current is increasing. When the current is increasing, that current, electric energy, is changes into magnetic energy and store up in the magnetic field induced by the inductor. So during this increase, energy store up in the induction coil in the form of magnetic energy. When the current is decreasing, what happens? To oppose this, what is that? The voltage or EMF, it decreases or gives out. So it gives out the energy, that is energy is decreases, magnetic energy decreases when the current is decreasing this way. I said that during this phase, the energy is stored up. What is stored up is released this way, compensated. Store and release. Store and release, both are compensated in one direction. And after that, the polarity changes immediately. Current flows in the opposite direction. Here, energy store up and releases. So, energy store up and releases. Like this, it takes now what is that? One cycle. To have this effect, it takes time. Voltage in the same speed, but during this process, what is that? The induces the voltage and opposes the current. This induction, that is store up, release takes time. So it delays the flow of current. That is lags behind by a difference of pi by 2, phase difference. It is because of the effect of current. The phase differ by minus pi by 2. What about this one? It acts due to variation of voltage. That is just like what is that? Cell, or what is that? Open circuit. Plates are there. So these two charges because of application of voltage. So voltage, what is that? Voltage is not constant, is varying. Like this is similar now. Voltage is varying like this. Similar. Increase, decrease in one direction and the current is flowing in one direction. It is other way, it is not increase, decrease in other direction. And the current changes, it will change. Because of this voltage change, there is a charge and discharge. So when the voltage is increasing from here to here, it is getting charged. Suppose it plus and minus accumulated. It is getting charged. So that charging is known as energy store up. Electric energy is stored up in the form of electric energy in the electric field. Energy stored up in the electric field. So that is what is stored up. Why? What is that? Immediately what is that? Decreases. When the voltage decreases, here what is stored up will be released. So it is getting compressed again, no? Energy stored up, release. Energy stored up, release in one direction. Immediately what is that? Interchange polarity. So current flows in opposite direction. Energy stored up, release. So energy storing is electric energy in the electric field. That is electric potential energy in the electric field. Here magnetic potential energy in the magnetic field. Difference. Both are energy storages. It stores the electric energy in the form of electric potential energy in the electric field. Electric field between these two. It stores up electric energy in the form of magnetic energy, magnetic potential energy in the magnetic field. The difference. But will not dissipate it like this. Store up and release. Store up and release. Current flows. But during the store up and release, it takes time. That is why it is lagging behind. Which one? Voltage. Voltage lags behind the current. So that is the reason. In this case, voltage is lagging behind the current. Here, current is lagging behind the voltage. It works on the principle of variation of current because AC is a variation of current. And it works on the principle of variation of voltage. Therefore, voltage is lagging behind. That is the difference. What is that? Look at the difference, main differences. They are in the same phase. But these two are not in the same phase. Current lagging behind. Yes, current leads. Current lags the voltage. Current leads the voltage. Difference. These are the characteristic behavior of the induction coil and the capacitor. And finally, we should understand this equation of it now. I told Im is equal to Vm divided by omega L. Im is equal to Vm divided by omega L. What is omega? Angular velocity. L is the coefficient of inductance. That is self-inductance. So I can call this omega L and this as X and L for inductor. Omega L is equal to X. So that is why Vm by X L. So finally what is that? Im is equal to Vm by XL. Here you see that Im is equal to Vm into omega C. C stands for capacitance. Omega stands for angular velocity. So we can rewrite this as Vm divided by Xc, that is X. So Xc is equal to 1 by omega C. So if we take denominator as 1 over omega C, it is Xc. Xc is equal to X, C for capacitance. Look at these equations. In this equation, it is similar to these equations are similar to Im is equal to Vm by Xc, Im is equal to Vm by XL. In place of XL we have R. In place of XC we have R. So this is the equation similar to resistor. Here resistor acts as resistance. It restricts or opposes the flow of electric current. There is a similar effect. What is the effect here? It will oppose the flow of current by not like that, in a different way, by energy storing, energy releasing. But energy is dissipated here. Energy storing, energy releasing in the induction. So that is known as inductive reactance. This kind of resistance is known as inductive reactance. Here also. Here capacitive reactance. X stands for reactance. X stands for reactance. C stands for capacitor. Capacitive reactance. Inductive reactance. Same function it has. Resistance. Just like this resistance will oppose the flow of current in the AC circuit, but concept is different. It is by what is that? Storing the electric power in the form of electric energy and releasing. That is electric potential energy and releasing. So both of them are storage, but energy storage, kind of energy storage is different. Magnetic potential energy, electric potential energy is stored. That is, in that what is that? Storing, releasing, but there is no dissipation, no loss. So that way will oppose the flow of current. That is, concept is different. And here XL is equal to omega L, but XC equals 1 over omega C. Look at the difference. This XL is directly proportional to frequency, angular frequency, and as inductance. What is angular frequency? 2 pi by T, 2 pi L. Frequency. What is frequency? How many cycles are generated in 1 second? There is one cycle. Another cycle. How many cycles like that generated in 1 second? That is called as frequency. This XL depends on F. Higher the frequency, higher the value. Higher the frequency, more resistance to flow of current in the form of this. But here different. Omega C. Omega is in the denominator, 2 by F. This Xc is inversely proportional to frequency. So lower the frequency, higher the Xc, and vice versa. Lower the frequency, higher the Xc. If the frequency is low, this effect is more. What effect is that? Opposed to the flow of current is more effective. But here, opposed to the flow of current is more effective when the frequency is more. Look at the difference. So it also depends on L and E, directly proportional to this L value, inversely proportional to C value. So overall, this reactance, capacitive reactance, inversely to these functions, and inductive reactance is directly to these functions. Higher the frequency, higher the inductance, and higher the effect. Lower the frequency and lower the capacitance, higher the effect. Capacitive reactance. So that is the importance of these two. So these two, in other words, they'll control the current here and control the voltage here. This will control the voltage, stabilizes the voltage. This will stabilizes the current. That is applications. And the characteristic behavior, that is what I explained. Mathematical approach and final result. Using the result, we can understand the meaning in the form of graphical representation. These two are very important. So this is I have taken only a pure resistor, pure inductor, and pure capacitor. And if you take in the combination, there is series, parallel, and different components. What is that? What is the effect? That is a different subject. Thank you.